what we're looking at here is the idea of parallel and perpendicular lines. So, and those lines are linear equation, graphs of linear equation. So basically, parallel lines are like this, and perpendicular lines are like this, which intersect at 90 degrees. Parallel lines never touch. Perpendicular lines touch once. Now, if lines are parallel, if they never touch, what do you notice about this? What do you notice about them? What do they have that's in common? Well, they have, so we've got y1 here. It's y1. Now this one is y2. Hopefully you've seen that both of them have the same gradient. So m1 equals m2 if they're parallel. So they have the same gradient. They'll have different y-intercept, but they have the same gradient. Now, if lines are perpendicular, and we've got y1 over here and y2, that means that m1 equals negative 1 over m2, and likewise m2 equals negative 1 over m1. So what we do for here is what we call the negative reciprocal. So it's the same number, but just we put a 1 on top of it and make it negative. Okay, let's see how this works. So for us to determine if lines are parallel or perpendicular, we've got to make sure they're written in the form y equals mx plus c. If they're written in this form, well then we can easily see what the gradient is. If they're written in this form, we've got to convert it to this form. So this one, we asked to find the gradient here. Some people straight away say it's 2 because the coefficient of x is our gradient, but it's not written in this form. That's what we've got to do. So with this one, I'm going to take the 2x, move it over, so I'm going to subtract 2x from both sides. So we're going to have 4y equals 4 minus 2x. I'm going to now divide both sides by 4. Y equals 1 minus 2 for x. So it ends up being, I always write our x term first. So this will be negative 2 over 4. Alright, we can simplify that as well. 2 over 4 simplifies to what? Simplifies to a half. A half x plus 1. So here the gradient to this is negative a half. So anything parallel to that would be negative a half. Anything perpendicular would be negative 1 over 1 over 2, which ends up just being 2. We need that negative there as well, so that's a negative. So if it's parallel, any gradient will be a half. If it's perpendicular, anything will be 2. So what we're going to do, I'm going to try and see if I can move this thing. No, not letting me. We're going to use this equation, y equals 3x plus 4. And now we're looking for a line that is parallel, that passes through point 0 and 6. And look for one that's perpendicular, that passes through 1 and 4. So this is parallel, and this is perpendicular. Let's see if we've got enough space. So we're going to find the equation to a line that is perpendicular, parallel to this, that passes through 0 and 6, an equation to a line which is parallel, which is perpendicular to this, which passes through 1 and 4. So to do that, what we do, if it's parallel, well then, we know parallel lines have to have the same gradient. I'm going to change colours. So if parallel lines have the same gradient, we're going to have y equals 3x, same gradient, plus c. We're going to try and work out the y-intercept. Now, we want it to pass through 0 and 6, so we substitute 0 for x and 6 for y. So we'll have 6 equals 3 times 0 plus c. So 3 times 0 is 0, so it tells us that c equals 6. So y equals 3x plus 6 is the equation. Okay, now for the other one, we want to see if it's perpendicular to 3x plus 4 and pass through 1 and 4. What we do is substitute. So we've got to take the negative reciprocal. So it become y equals negative 1 on 3 x plus c, which we don't know. So from there we know we can pass through 1 and 4. So we have 4 equals negative 1 over 3 x. Oh, sorry, that's going to be x. That's going to be 1 plus c. So this ends up being 4 equals negative a third times 1, negative 1 over 3 plus c. So that comes over to the other side. So it's going to be 4 and 1 over 3 equals c. And that'll simplify to 12 over 3, 13 over 3 equals c. So the equations being y equals negative 1 over 3x plus 13 over 3. So, if one's a parallel, that's an gradient. If they're perpendicular, one is a negative reciprocal of the other one. So put a negative 1 on top of our number, and that's what it ends up being. If you're asked to determine if two lines are parallel, you're checking to see if they've got the same gradient. So if they write it in this form, make sure it's written in this form. You've got to know y equals x plus c. The other thing you'll be asked to do is to find the equation to a line which is either parallel or perpendicular to a line they give you, and then tell you that it passes through a certain point. So if they tell you it's parallel, you set the same gradient, substitute your values for the points, and solve for x. And solve for c. If they tell you that it's perpendicular, you take the negative reciprocal, substitute your values, and solve for c. That's how you find that. That's the things that you'll be asked to do for parallel and perpendicular lines.